Base is the region enclosed by y equals sine x from 0 to pi, and each cross-section is an isosceles right triangle whose hypotenuse is lying perpendicular to the x-axis. So visualizing this, we have sine x from 0 to pi, and each cross-section is perpendicular to the x-axis, so it's dx thick, but it's an isosceles right triangle shooting out from that cross-section, or from that slice. So the area of an isosceles right triangle is 1/2 leg squared because the base and the height are the same. In an isosceles right triangle, the hypotenuse is equal to the leg times square root of 2. So your leg is your hypotenuse divided by square root of 2. But they told us that the hypotenuse is lying perpendicular to the x-axis, so that hypotenuse is sine x. So your leg is sine x divided by square root of 2. Now we have everything we need to set up our volume integral. Volume is the integral from 0 to pi, and the area of our cross-section is 1/2 leg squared multiplied by the thickness, and our leg is sine x over square root 2. So this volume is 1/4 integral from 0 to pi of sine squared x dx. I picked this example on purpose because whenever you're integrating sine squared or cosine squared, you will need to use a special trig identity. So this is equal to 1/4 integral from 0 to pi, and sine squared x is 1/2 minus cosine 2x dx. And cosine squared is the same except for you're adding. I'm going to now do a little u sub. U equals 2x. That means 1/2 du equals dx. U of 0 is 0, and u of pi is 2 pi. So our volume formula is now 1/16 integral from u equals 0 to 2 pi of 1 minus cosine u du. That equals 1/16 u minus sine u from 0 to 2 pi. So that's equal to 1/16 2 pi minus sine of 2 pi. So that becomes pi over 8 units cubed.